Hello guys, this is Napoleon. I'm back with another video. We finding the derivative of the cosecant x. So finding the derivative of cosecant x using the definition of limits or using the first principle. So this is the equation of the first principle where the limit as h approaches 0 of f of x plus h is subtracted by f of x divided by h. So what you need first, you need to substitute in the formula. So note that this represent the derivative f of x. This represent the derivative that we are finding the derivative. It's either you use you're going to use a d over dx or y prime. So it depends what you are given. If you're given f, you're going to use f prime. So it's f prime. So note that f prime is actually different from f inverse of x. So these are different notations which you need to be aware of, so don't get lost. So back on the, you substitute what you are given. You substitute your cosec plus h, x plus h minus cosec of x. Then after that, let's remember a few things. 1 over sine x is equals to cosec. So never forget that. Because you are always, when you are using, you are given a cosec and you need to derive it, you will actually be needed to convert it into 1 over sine to make it more simpler for you to solve it. Therefore, the next step, since you are having a fraction on top of another fraction, therefore you cross multiply to find the common denominator. So we are trying to find a common denominator, so you cross multiply and also multiply the base together to find the lowest common multiple. Then you get sine x. Let's focus here. You get, when you cross multiply, you will get sine x. Sine x multiplied by 1 is sine x minus 1 multiplied by sine x plus h. So that will be divided by the multiplication of the two denominators we are having up there, divided also by what? By h. So don't forget to write the limit. The limit is very important. Therefore, you actually here On this step, you multiply here, you multiply your denominator with h. So the reason we are multiplying with h is because if you take this is h over 1. Therefore, when you are moving from division, when you are moving from division to multiplication, you need to, then this will be h over 1 over h. Then when you multiply, the numerator is divided, it's multiplied by 1, and the denominator is multiplied by h. Therefore, you get this. Then on this step, you actually find what is sine x plus h. So we have a special formula of what is sine plus h. So sine plus h will give us a sine x cos h plus sine h cos x. Therefore, after getting that, you multiply. Here you are having 1. You multiply the 1 throughout the brackets, therefore it's going to give you a negative. So here you are having negative, and even here you are having negative. You therefore apply the rules of limits. So the rules of limits states that the sum of a limit is a limit of a sum. So that means you can subtract this, you can rearrange the limits in a suitable way. So here we decided to arrange the limits in, so we took this, we divided by our denominator, and we also took this and divided by our denominator as well. So by doing that, we got this. So now you need to remember the rules of limits. So there are two special limits we are looking for in this case. There are two limits we are looking for. The first limit is x minus 1 minus cos of, it might be x or any variable, divided by that variable. This will give us 0. The limit of this, let me write to show you that it's a limit as x approaches 0 of this will give us 0, and the limit, let me write down here, the limit of sine x divided by x. So let me write the limit as x approaches 0. Okay, 0. This equals to 1. Therefore, looking into our limits here, we are going to find these special limits. So here we are having h, and we are having 1 minus cos h, and this side we are having sin h, then we are having h here. Therefore this will give us 1 as our rule of, or our special case states, and this will give us 0, and multiplying throughout here, multiplying here with 0 will give us 0, and dividing by 0 will actually give us 0. Therefore this entire limit will equate to 0. Therefore we'll be left with the right hand side limit only. And it seems like I am identifying some, let me see. It seems like I did a very terrible mistake over here, and this was supposed to be multiplied by cos. So I forgot cos of x. So I made a mistake while typing this, sorry with that. But since this will actually equate to 1, so it's 1 multiplied by cos, which will actually just give us cos of x. Then now we are having a negative limit as h approaches 0 of cos divided by h sin x plus h sin multiplied by sin x. Therefore we substitute. Remember, when you're substituting, you need to remove your limit as h approaches 0, as you are actually substituting that 0 into the equation. Therefore our h equal, we are going to substitute 0 on the place of h. Therefore we are going to have cos divided by sine multiplied by sine, which can be sine squared, but in this case we are not interested into it being sine squared, but we are interested in this. So we are going to rearrange our equation here, where 1 over negative 1 over sine x is multiplied by cos x divided by sine x. So we know that identity, this identity, cos over x divided by sine is going to give us cot x, and 1 divided by sine x is going to give us a cosec, which it's negative since we are having this negative sign here. Therefore this is our derivative of cosec. I hope you actually enjoyed and you fully understand on how to use the definition of limits or first principle into deriving cosec of x. So thank you. I'll show you how to derive other trigonometric functions and even more complicated functions using the definition of limits or first principle. So goodbye.